Chapter 3.1. In Chapter 3, we talk about the different types of averages, and those are mode, median, and mean. The mode is the easiest to find. It is the value in your set of data value that occurs most frequently or most often. Then we have the median. The median is the middle number. Now, what's important when you calculate the median is that you put your number in order from the smallest value to the largest value. We'll also be discussing the position or the location. So if you have, say, however many numbers, if the median is the third number, that would be considered the position or the location. Now, how you find that, I don't know if you can see this very well, but you use n, and n is the total number of data values, so n plus 1 divided by 2 it tells you not what the value of the median is, but the location of the median. And then the last average that we will discuss is the mean, and this is where you take the sum or add all your data values up and divide by however many there are. Now, I want you to get familiar with this right here. It's called X bar, and that is the labeling for the sample mean. So X bar is the summation of X over N, and then for the population, the mean is what we call mu. And that again is the summation of all the x's and then divide by n. All right, so what I've done in this page of notes is I've given us 3 different examples. So we're going to go through all 3 examples and we are going to calculate or locate the 3 different types of averages. Now, what I've done first, in this set, we have a total of 4 numbers. So n equals 4. That's the total number of data values. Now, notice what I've already done is I've placed them in order. That 1 helps me find the mode easier, and secondly, it makes sure that I calculate the correct median. So when I look at my set of numbers, I see that there are 2 3s, so the mode is 3. The median is the middle number. Now, if I wanted to find the location, I'm going to do that first. That's n, which in this case n is 4. So it is 4 plus 1 divided by 2. So 5 divided by 2 is 2.5. Now here's where you need to be careful. 2.5 is not your median, that's the location. So that tells me that my median, if you think, where's 2.5 on a number line? It's between the numbers 2 and 3. So it is between the second and the third number. Well, here's my second and third number. The median is between these two. Now, when your median is between 2 numbers, then you just average them. So we would do 3 plus 7 divided by 2, so that's 10 divided by 2, or 5. So in this case, my median is 5. Then the mean, which is X bar, this is the summation of all of these values. So 7 plus 3 is 10, 18, 19, 20, 21. So I add all those up and I get 21, and there are 4 of them. So I'm going to do 21 divided by 4. And if you go to your calculator and do 21 divided by 4, you get 5.25. So X bar, or the mean, is 5.25. Then we have a second example, which we have more numbers. We have 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 values, so I say n equals 8. I first am going to place them in order, and when I do, and I'm going to locate the mode, I see that the 5 and the 9 both have 2 of them. So in this case, there are 2 values that are the mode, and that can occur. There can be multiple values that are the mode. Now, what is the location of the median? There's 8 values, so we would do 8 plus 1 divided by 2. That's going to be 4.5. 4.5 on your number line is between the 4th and the 5th number, so 1, 2, 3, 4. So our median is between the 4th and the 5th number. And again, it's between 2 values, so I'm going to average those. 5 plus 6 divided by 2, that is 5.5. So my median is 5.5. Then to find the mean, and I want you to get used to using X bar for the mean, you're going to add all of these values up. So 2 plus 3 plus 5 plus 5 plus 6 plus 8 plus 9 plus 9, and you get 47. So you would have 47 is the summation. There are 8 values, so I'm going to do 47 divided by 8 on my calculator, and I get 5.875. Now, that's a terminating decimal, so I just gave it all. If you have a repeating or a decimal that goes on forever and doesn't repeat, just use normal rounding rules and give me a minimum of 2 decimal places. All right, then the third example, again, I have, let's see, 1, 2, 3, 4, 5, 6, 7 values. So n equals 7. I've already placed them in order. So the first thing that I'm going to do is see what value or values is more frequently listed than the others. And if you'll notice, there's just one number of each. So in this case, there is no mode. There is not a number that is listed more frequently than the other. So that can occur. All right, the location of my median, I would do n, which is 7. So 7 plus 1 divided by 2, well, I can do that one in my head. 8 divided by 2 is 4. So it tells me that my median is not the value 4, but it is the fourth number. 1, 2, 3, 4. So it tells me that this is my median. And in this case, since I had an odd number of values, I didn't have to do any averaging. So 10 is my median. So my mean, again, X bar, is I add all of these values up, which when you add them, you get 78, and there are 7 values, so 78 divided by 7, and you get 11.14. So there are 3 examples of finding the mode, the median, and also the mean. Now we're going to look at some application problems, still calculating those. All right. In a course entitled Experimental Psychology at Regis University, students train white rats to do various tasks based on a performance reward theory. So one event is the hurdles. So what they've done is they have 1, 2, 3, 4, 5, 6, 7. So that means 7 rats ran the hurdles, and this is their time in seconds. Now notice what I did first is I placed them in order. So 1.8, that's a pretty quick rat. He ran the hurdles in 1.8 seconds, all the way up to 5.2 seconds for another rat. So the first thing it asks is, what is the mode? So what number is listed most frequently? That would be the 3.3. The location of the median, there are 7 values. So 7 plus 1 divided by 2, that's 8 divided by 2 is 4. So 1, 2, 3, 4. So as long as my numbers are in order, then I know that fourth value of 2.9 is my median. Then to find the sample mean, add all of these numbers up on your calculator. And when you add them up, you get 21.6. And there are 7 numbers, so I'm going to divide by 7. So 21.6 divided by 7 is 3.09. Then they took those rats, maybe different rats, I don't know, and this time they climbed a ladder. So 1, 2, 3, 4, 5, 6, 7, 8. So now we have 8 rats instead of 7. I've placed them in order. 5.1 seconds is 1, all the way up to 41.9 seconds. Now if you'll notice, this number is quite a bit larger than all of the others. That value is what we call an outlier. An extremely large in this case, or an extremely small value in relationship to all the other data values is considered an outlier. All right, so the first thing that we are asked to find is the mode. So there's 2 6.6s, And it looks like that's it. So 6.6 is my mode. Then the location of the median, in this case, there are 8 values. So I would do 8 plus 1 divided by 2 and get 4.5. So that tells me the median is located between the 4th and the 5th number. 1, 2, 3, 4. Between the 4th and the 5th number. So to find the median, I would do 6.6 plus 6.9 and divide that by 2, because we're just going to average those two numbers, and we get 6.75. And then the last thing is the sample mean, or X bar. So we add all of these values up, and it adds up to 88.2. And we're going to divide by 8 because that's the total number of values that there are. So we get 11.025. So there's how you calculate the mode, median, and mean. And if you'll notice, this value is quite a bit larger than the mode and the median. Why? Because the outlier pulled that number up. All right, the last page of notes for this section is still talking about the mean, but now we're looking at what is called the trimmed mean, and it's just that. We're going to trim up some numbers. All right, here's how you do that. First off, we'll either do a 5% trimmed mean or a 10% trimmed mean. We're never going to do like 6% or 12%. It'll either be 5 or 10. So assume we have 100 values. So N, the total number of data values, is 100. So to find the 5% trimmed mean, you take the number of data values times 5, which equals 5. Now here's where you need to be careful. This 5 tells me to trim the 5 smallest numbers and the 5 largest numbers. So on a 5% trimmed mean, in this case, you are actually trimming a total of 10 numbers, even though you calculated the number 5. That's where you need to be careful. Then, the remaining 90 numbers, you find that mean. Now, if you were doing a 10% trimmed mean, you would take the total number of data values, 100, times 10%, or 0.10, and you get 10. Now, again, this 10 means trim the 10 smallest and the 10 largest numbers. So in actuality, you are trimming a total of 20 numbers, which means you would take the remaining 80, add them up, and divide by 80. So if you'll look in your book, the guided exercise 2 on page 86, it is giving you the size of lecture courses. I think it's an introductory to English or literature. Okay, so there's 20 courses that they looked at. And if you'll look through that example, the first part of it, it finds the mean, or X bar, of all 20. So it added them all up and divided by 20. And then it asked to find a 5% trimmed mean. And this is the thing that I want to show you. So they took 20 times 0.05, and you get 1. Now, this is where you need to be careful. That means trim the smallest value and the largest value. So you're going to trim a total of 2 values. Then what you would do is you take those remaining 18 numbers, add them up, and divide by 18. If you were asked to find the 10% trimmed mean, you would take 20 times 0.10, and you get 2. Now again, be careful. That means you're trimming the 2 smallest values and the 2 largest. So you're actually going to trim 4 values, which means you take the remaining 16 numbers, add them all up, and divide by 16. Now, in that example, when we multiplied times 5% or 10%, we got a nice, neat whole number. What happens when you don't get a nice, neat whole number? Because, as we all know, life is not always nice and neat. So here's how you handle that. Say we had 168 data values, and we were going to find the 5% trimmed mean. So I take 168 times 0.05, and when you do that on your calculator, you get 8.4. So at this point, what you're going to do is use your normal rounding rules. So that would round to 8. And that tells me to trim the 8 largest and the 8 smallest values. So you would trim a total of 16 values. If you took that same 168 values and did a 10% trimmed mean, you'd take 168 times 0.10 and you get 16.8. Use normal rounding rules, which would round to 17. So you're going to trim the 17 smallest numbers and the 17 largest numbers. So you would trim a total of 34 values. So that's how you handle a trimmed mean. That is chapter 3.1.